The universe has billions of galaxies, each with billions of stars, and everything follows the same basic rules. Gravity pulls things together, light travels at the same speed, atoms behave the same way everywhere. These laws of physics are so precise that if we changed any of them just a tiny bit, you wouldn't be here watching this video. In fact, nothing would exist. But here's what changes everything we thought we knew. These perfect laws that control literally everything might have emerged completely by chance, arising from a nothingness that our minds can't even imagine. Imagine trying to write a book by throwing random letters and having them organize themselves into a perfect story. That's what the universe did, but on an infinitely larger scale. How did absolute nothingness create rules so complex that even today we can't fully understand them? Subscribe to the channel, leave your like and comment from what part of the world you're watching, because now I'm going to tell you everything. What does it really mean for something to come from nothing? Imagine for a moment that you take away everything you know. Take away the stars that shine in the night sky. Take away the ground and the air. Take away your own body and even your thoughts. Now, take away space itself, so there is nowhere to stand or float. Take away time, so there is no before or after. In this place, there is not just emptiness. There is not anything at all, not even the possibility for anything to exist. This is what scientists mean by nothing when they ask how the universe began. They do not just mean a quiet, dark space. They mean no place, no objects, no moments, and no rules. If you try to think about it, it feels impossible. Everything you have ever known happens in some place, at some time, and follows certain patterns. But scientists believe that before the universe began, none of these things existed. This leads to a great puzzle. If there was truly nothing, how did something, anything, appear? Most important of all, how did the rules that control everything appear? These rules are called the laws of physics. They decide how things work in the universe. They tell matter how to move, how energy can change, and which things can happen. If there were no space, time, or matter, then there were no laws either. So where did they come from? That is the first mystery at the heart of our story. If we look at the world around us, everything follows rules. When a ball rolls down a hill, gravity pulls it. When you turn on a light, electricity follows wires and makes the bulb glow. Even your heart beating or your thoughts moving from one idea to another are parts of patterns guided by these rules. The whole universe, from the largest galaxy to the smallest particle, works this way. But before there was a universe, there was no ball or hill, no bulb, and no galaxy. Was there anything at all? Scientists have tried to understand where the universe came from for a very long time. People can use telescopes to look far into space, and when they do, they are also looking back in time. The light that reaches us from distant stars left them long, long ago. The farther away we look, the older the light is when it finally reaches us. But even with the biggest telescopes and the most careful measurements, there is a limit. There is a point we cannot see past. No telescope or camera can show what happened at the very start. This makes the mystery even deeper. If you want to figure out what happened at a certain moment, you usually look for clues. Maybe you find footprints or a trail or a photograph. But when it comes to the beginning of everything, there are no obvious clues at all. The place before the universe, if we can call it a place, left no marks. There is nothing to analyze, no message from the past. This is why people say the start of the universe is a puzzle like no other. To understand it, scientists first had to think about what nothing really means. In everyday life, nothing can mean an empty cup or a room with nobody in it. But here, nothing is a much stronger idea. It means no space, no time, and not even the possibility for anything to start. It is not just empty, it is the absence of anything and everything. There are no objects, no movement, and not even a way for things to be arranged. If you try to imagine this true nothing, your mind might try to fill the gap with something, even a blank space or a pause in time. But scientists say that is not real nothing. Blankness is still a kind of something you can think about. Real nothing means not even a place to put anything. So the question becomes, how can something, anything, arise if there is nothing to begin with? And, even more oddly, how do the rules for how things work arise if there is nothing, not even a stage, for them to act on? This is where the puzzle reaches its hardest point. Some people might say that things cannot come from nothing. They might say that there had to be something else before the universe, maybe something hidden that we do not know about. But when scientists look at the universe we live in, they see no clear sign of anything before the universe began. Everything we can study starts with the moment the universe appears. The laws of physics are also part of this problem. These laws control everything that happens. They are not made by people. They are not rules written down in a book. They are ways the universe works, found by watching and measuring. For example, gravity always pulls things together. Light moves at the same speed every time. These patterns and numbers are part of the fabric of the universe. They let things form and change in regular, reliable ways. But if there was a moment before these laws, then in that before, even the idea of things behaving in regular ways does not make sense. There is no before and after. There is no way for one thing to turn into another. So it is almost as if the universe and its rules had to appear together, both at the very first instant. This idea is hard to explain with words because there are no examples from our daily lives that match it. It is a kind of change that is not really a change, because before it, there is no time. It is a beginning that is not like the start of a book or a song or a trip. Those things all start at a certain moment in time, in a place that already exists. But the beginning of the universe is the beginning of everything, time itself, space itself, and the laws that fill them. Sometimes when people talk about this moment, they use the word creation. But in science, the question is not just about how the universe was created. It is about whether the word creation even makes sense when there is no time or place for anything to be created in. The mystery of the beginning touches other questions too. If the universe and its rules came from nothing, is it possible for nothing to make anything at all? Would the laws of physics allow this? Or is there something deeper we do not understand? For a long time, people wondered if maybe the laws of physics just exist in some way outside the universe. But if that were true, where would they be if there is no space or time or anything at all? This question seems impossible to answer. Scientists have tried to build ideas and models that can help us think about this. They try to find ways to put this hard problem into questions that can maybe be answered with math or careful thinking. But the beginning is special because there are no earlier moments to use for clues. Still, by looking at the universe today and seeing how well the rules work, scientists believe there must be some way the laws of physics appeared together with the universe itself. The first moment of the universe has a special name: the Big Bang. This is not like an explosion with sound and fire, but it is a way to describe a very sudden start. At the moment of the Big Bang, there was suddenly space and time. There was suddenly energy and matter. The laws of physics as we know them began to control what could happen. Before this, there was no way to even talk about before. There was no clock to mark ticks of time. Space did not have any points or distances. In that instant, everything that could ever exist began, including the rules. Some scientists say the laws of physics might be emergent. That means they come into being at the same time as the universe. If there is no universe, there are no laws. As soon as the universe appears, the patterns we call laws appear too. The laws of gravity, of light, of atoms, all switch on with the first moment. This is a big idea. It means the universe and its rules are tied together. They are not two different things, but two sides of the same start. Without space, there is no room for the laws to be true. Without time, there is no way for laws to work from one moment to the next. The rules cannot float alone, waiting for a universe. They only exist when the universe does. There is another way people think about the start. Some say, maybe this is not the only universe. Maybe there are many other universes, each with their own rules. This is a different idea called the multiverse. But even in that idea, the same question pops up. Before any universe exists, where do those laws come from? What sets the rules for each new universe? The puzzle just moves from one kind of nothing to another. Scientists know that the question of the beginning is very hard to answer, but it is an important question. If we could understand how something comes from nothing, we might understand how it is possible for anything to exist at all. We would know something about how the universe started, and maybe even why the rules are just the way they are. Right now, we have no way to see or test anything before the first moment of the universe. All our best tools, telescopes, and experiments only show us things that happened after the start. The oldest light we can see is from about 380,000 years after everything began. Before that, the universe was too hot and dense for light to travel. It left no direct sign behind. Still, scientists keep searching for the smallest clues. They look at how matter is spread through space. They measure the oldest light with great care. They use math to build models and check if any pattern today gives a hint about how the very first moment went. Even though the mystery is deep, people keep asking the question, what does it mean for something, anything, to come from nothing at all? How could the rules that run the world appear from nowhere with no cause, in no place, at no time? By thinking about these questions, people learn not just about the universe, but about the limits of what we can know. The question of the beginning is special because it touches every part of science and thought. It is the root of everything else. Without understanding the beginning, we cannot fully know why the universe is the way it is, or why the laws of physics are so exact. When you look up at the stars tonight, you are looking at part of this mystery. You are seeing a universe that works in a certain way, with patterns and rules. The same rules that shape the glow of a distant star shape your life here on Earth. Behind it all, there is a question so big we still do not have an answer. How does something come from nothing, and how did the rules for everything appear in the first place? For now, that question remains at the very center of science, the first and deepest puzzle of existence. When we look at the universe all around us, we see order. Stars move in paths, the sun rises and sets every day, the moon shapes the tides, and rain falls when clouds grow heavy. Flowers open in the morning light, rivers flow down mountains, and birds return every season. All these things, big and small, seem to follow certain patterns. These patterns are the reason our world feels stable and trustworthy. If you throw a stone into a pond, you know it will make a splash. If you let go of a ball, it falls to the ground. If you flip a switch, a light turns on. Whenever people watch the world, they notice things happen in regular ways. Step by step, these everyday patterns are the first signs that there is something more underneath everything we see. This something more is what scientists call the laws of physics. The laws of physics are not rules made by people. They are not laws written in books by governments or leaders. These laws do not change when people travel to other places. They are not different in the mountains, or by the sea, or in the city. Instead, the laws of physics seem to be built into the way everything works. They are part of the universe itself. All things, from the smallest speck of dust to the largest galaxy in the sky, act according to these laws. Scientists learned about the laws of physics by paying careful attention to what happens around them. They watched how things move, how things fall, how things change. When something happened the same way, again and again, they wrote down the patterns they saw. Over a long time, as scientists learned more and made better tools, they found new laws. Sometimes they changed old laws to make them work in more cases. But at the heart of all this work, one idea remained: that the universe is shaped by regular rules. There are many different laws of physics. One important law describes gravity. Gravity is the force that pulls objects together. It keeps our feet on the ground, holds the planets in circles around the sun, and shapes galaxies. Another law describes how light travels. Light always moves at the same speed. This speed is never faster or slower no matter what. There is a law for how electricity flows through wires. There is a law for how atoms stick together to make everything we see. There is a law for how objects keep moving unless something pushes or pulls them. Each of these laws tells us how a part of the universe works. These rules are not just guesses. Scientists test them many times. They use experiments, measurement, and careful observation. Only when something happens the same way every time do they say it is a law. For example, if you drop a feather and a coin in a place without air, they fall together at the same rate. This shows the law of gravity works the same way for different objects. If you run electricity through a metal wire, it will warm up. If you connect a light bulb, it glows. The world follows these rules over and over. Scientists often write the laws of physics using math. Math helps explain how much, how fast, and how far. One law of motion says that when you push something, it moves faster. The bigger the push, the faster it goes. The heavier it is, the harder it is to make it move. Another law says if you know how one thing moves, you can predict what will happen next. These are simple ways of describing what happens, but they work for everything from falling apples to rockets flying into space. The laws of physics are not about just one part of the world. They are everywhere. If you travel to a faraway planet or to the edge of the universe, the same laws hold true. Scientists have looked at light from stars many light years away. They see that the rules for how light bends or travels have not changed, even after the light has been moving for billions of years. The laws of physics do not stay local to one place or one time. They appear to be the same everywhere and always. Every discovery of a new law helps scientists understand how the universe works. For a long time, people thought different things happened for their own special reasons. When it rained, they did not always know why. When lightning struck, it was a surprise. Over hundreds and thousands of years, people noticed patterns. Once telescopes and other tools grew better, scientists could test ideas about the sun, the stars, and the planets. They could make up new rules and see if nature followed them. Every experiment made them more certain that the laws of physics rule everything in the universe. One simple example is the way planets move. Long ago, people watched the stars slowly drift across the sky. They watched the planets wander in strange paths. Some stars rise and set, others seem to move backwards from time to time. For many years, these movements were a mystery. But then, scientists like Isaac Newton found a law, the law of gravity, that explained how it all worked. Gravity connects everything with mass. It pulls on planets, stars, and even the air you breathe. Another important law describes how things change over time. If you light a candle, it burns smaller and smaller until nothing is left. If you break a glass, the pieces stay broken. It never fixes itself. These changes happen in one direction. Scientists call this entropy, a law about how energy spreads out and things grow less ordered over time. The law of entropy explains why eggs break, ice melts, and people grow older. Every part of the universe, from cells in your body to stars in the sky, follows this rule. The laws of physics even control things that are very tiny. Atoms are so small you cannot see them without special machines. Atoms join together to form everything in the world: rocks, water, air, and living creatures. There are laws for how atoms link, break apart, and send out light. These rules are very precise. At the tiny scale of atoms and smaller particles, physics can sometimes work in strange ways. This part of science is called quantum mechanics. In quantum mechanics, some things happen with no clear reason, almost like chance. Even these strange effects still follow their own laws. Even though there are many laws, they work together. When you look at the world, you see these laws acting at the same time. The sun shining in the sky is light following certain laws. Plants turning sunlight into food follow other laws. If you ride a bicycle, gravity, motion, friction, and balance are all in action. The world does not need anyone to watch or control it. Everything moves, grows, and changes on its own, following these laws. The laws of physics are important for another reason. They make it possible to predict what will happen. If you know the starting point and you know the rules, you can work out what comes next. That is why engineers can build bridges and send probes to other planets. Doctors use these rules to help save lives. Farmers use them to grow food. Every machine, every medicine, every tool in your life is possible because the laws of physics are reliable. They do not change. Some of the rules are simple to describe. Others take a lifetime to understand. Some laws are written as simple equations with only a few parts. For example, the law of gravity can be written in one short formula. Some laws, like those for very small particles, need long and complex math. But all these ways of writing are just ways to describe the deepest truth, that everything in the universe works in regular, understandable ways. Sometimes people wonder, why do these rules exist? Could the universe work with different rules? Are the rules of gravity, light, and atoms the only way things could be? When scientists look closely at these rules, they notice something very special. The numbers in the laws of physics are just right for the universe to form as it did. If gravity were a little stronger or weaker, stars and planets might not form. If atoms stuck together in a different way, no life could grow. If the way light moves was changed, the universe could be dark and empty. These facts make scientists ask deeper questions. Are there reasons why the rules are just as they are? Are these numbers an accident, or is there some hidden pattern? Some scientists study whether the laws could have been any different at all. They look for signs that the laws of physics might have changed over the life of the universe. So far, every test shows that the main rules have never changed. Some people have suggested that there could be more rules than we know. Maybe there are hidden parts of the universe, or new particles and forces nobody has detected yet. Scientists keep building better machines and making more careful tests, looking for signs of new laws. Sometimes their experiments show tiny effects that need new explanations. When that happens, scientists work to find new rules that fit the new findings and check if they match with all the old data at the same time. Over time, several laws have been joined together into bigger ideas. For example, at first, gravity was separate from the laws about electricity or magnetism. But later, scientists discovered these forces could be explained in one idea using better math and experiments. Right now, scientists are trying to join more and more rules together. They hope someday there will be one simple idea, one law that explains everything in the universe at once. This search has led to some of the biggest questions in physics. Understanding the laws of physics does not just explain how things work. It also shows how everything is connected. The same law that holds an apple to the ground holds the moon to the earth. The same law that describes the path of a rocket describes dust falling from a shelf. The rules are part of the fabric of the universe, shaping what it looks like, what it can become, and what is possible. If the rules were different, everything would be different. The way we live today is a result of knowing these laws. People learn to build machines, grow food, send messages with light, and fly airplanes because the laws of physics are the same every time. If the laws changed one day, nothing would work as expected. Your car would not start, your laptop would not switch on, and even the air you breathe might not stay in your lungs. Physics is not finished. Scientists still study the world and ask questions about how things work. There are still mysteries. What happens inside a black hole? Why does gravity have the strength it does? Are there forces we have not found? Every time scientists find a new law, a new truth, it leads to more questions. Step by step, these answers lead people closer to understanding the whole universe. The most amazing thing about the laws of physics is that they allow life to exist. The air is the right blend for breathing. The sun gives just enough light and heat. Water can be found in lakes and rivers because of temperature and pressure. The ground holds roots to grow plants for food. The human body, with its cells and thoughts, works only because the laws are balanced just right. If any law was a little different, life as we know it would not be possible. The fact that these laws are so finely tuned makes many wonder if there is a deeper explanation for where the laws come from. Scientists keep testing for small changes, but the laws still hold. No matter where or when we look, they are the same. The search for the meaning of these laws leads scientists from the tiniest particles to the farthest stars. They keep looking for one rule, one answer, that can explain why the universe takes the shape it does, and why the numbers in the laws are just right for life and for everything we see. As people search for deeper understanding, they learn that these laws are not just facts about the outside world. They shape our lives and thoughts every day. Each time you look at your hand, see a bird fly, watch rain fall, or see a star in the night sky, you are seeing the laws of physics in action. They are invisible, but their effects are everywhere. When we wonder about where these laws come from, why they exist, and why they are shaped just so, we are really asking about the very heart of the universe. The next piece to think about is the moment when the universe and these laws first began, and how everything came into being at once, joining the rules and the world into a single story of existence. When people look back to the very start of everything, they want to know how the universe came to exist with all its laws. All the rules that guide how matter moves, how light travels, and how energy flows must have come into being at some point. This beginning is what scientists call the first moment of the universe. The important question is how space, time, and all the rules began, because before this moment, none of these things existed. Scientists have studied light from distant stars, the behavior of atoms, and the way galaxies move. Everything they observe points back to a time when the whole universe was very small, very hot, and very dense. This was not just a crowded place in space. Instead, space itself was extremely compressed. There was no clear outside or edge. Everything that would later become stars, planets, and even the air and water on Earth were squeezed into this early state. This first moment is known as the Big Bang. The Big Bang is not an explosion like a bomb or fireworks. Instead, it is when space and time began to expand from a very tiny, incredibly hot point. Before this, there was no space, so there was nowhere for anything to be. There was also no time, so nothing could change or move. When people talk about the start, they mean the moment when both space and time came into existence together and all the laws of physics started to work at the same time. At the first instant, the universe was unimaginably small. There are no other objects in our daily lives that are this tiny. In science, this first state is sometimes called a singularity. In this tiny and hot beginning, matter and energy did not exist in clear shapes or structures. Instead, all the pieces that would become atoms, stars, and galaxies were mixed together as pure energy, squeezed together with no space between them. As soon as space and time began, everything started to change very quickly. The universe began to expand, which means the space between every part grew bigger. The energy cooled as the space grew. After a very short time, the energy changed into tiny particles. These were not yet atoms, but even smaller pieces like the ones that make up atoms: electrons, protons, and neutrons. During these first tiny moments, the laws of physics turned on. Before this instant, there were no rules. But now, gravity began to pull, light began to travel, and forces that shape matter started to work. These changes happened so quickly that they are hard to imagine. In much less than the blink of an eye, the universe grew from almost nothing to the size of a large ball. In a few more moments, it grew even bigger. The first stage of the universe is called inflation. During inflation, space itself expanded at an incredibly fast rate. This does not mean things moved through space, but rather that space stretched out everywhere all at once. This stretched out all the energy and particles and made the universe look smooth and even. Inflation only lasted a tiny fraction of a second, but it decided many things about what the universe would become. Because of inflation, the universe did not become lumpy, twisted, or uneven. Instead, it expanded smoothly and let everything inside it spread out evenly. After inflation finished, the universe started to cool down enough for particles to join together. At first, it was still much too hot for atoms to form, but the new space gave everything room to move and settle. Light also began to move freely as the universe became less crowded. The paths of light carried information about these early times, and this same light can still be found today. Scientists call it the cosmic microwave background. This light is the oldest thing we can see, and it helps us understand what the first ages of the universe were like, even though it started about 380,000 years after the beginning. In these early stages, the laws of physics controlled every detail. The force of gravity began to shape how matter would pull together. Another force, the strong nuclear force, kept the centers of atoms firmly stuck together. The weak nuclear force allowed certain particles to change into other particles. The electromagnetic force decided how light and atoms would interact. Each of these rules worked together, making it possible for the simple particles to join up and form more complex structures. Over time, as the universe expanded and cooled further, tiny particles joined together to form the first atoms. Most of these early atoms were hydrogen, the simplest of all elements, which has only one proton and one electron. A smaller part became helium, with 2 protons, 2 neutrons, and 2 electrons. These simple atoms floated freely through space for hundreds of millions of years, while the universe was still dark and empty of stars. Later, small bumps or tiny differences in how much matter there was in different places led to the first clouds of gas. These clouds, pulled together by gravity, slowly got closer and closer. When enough gas piled up in one place, it got hotter and denser again. Eventually, nuclear reactions began in the center, and the first stars were born. This step from a plain, smooth universe to one with stars, planets, and galaxies was only possible because the laws of physics worked together perfectly. Gravity made clouds come together. Pressure and atomic forces decided how dense and hot they could get, and nuclear laws allowed stars to burn and shine. Light started to travel across space, and matter began to group into more and more complex shapes. From these first stars, new elements formed inside through nuclear reactions. When these stars ran out of fuel, they exploded and sent these new elements flying out into space. Over time, this spread the building blocks needed to form planets, moons, and everything we know. All of this, from the start to this moment, followed the same simple laws. The shape and story of the universe are written by these rules, starting from the very first instant. Another important thing is that as far as scientists can see, the same laws that worked at the beginning still work today. No matter where they look or how far they search, the rules for gravity, light, and particles do not change. This means the whole history of the universe, from the first tiny moment until now, has the same set of rules. Scientists have many questions about the first tiny instant. They wonder why the universe began with the rules it did. They wonder why space and time have the shapes and properties they do. They also ask if it was possible for other rules to appear, or if the start of the universe made these rules necessary. Some scientists try to look even closer at the very first moment before space was fully formed. This is difficult because the math and ideas we use today may not work in a place with no space or time. Some theories say that at this first point things were not separate. Forces and matter, space and time were all mixed together, not yet split into the parts we know now. After the first moment, as the universe grew, these became separate. Gravity, light, the strong force, and the weak force all took their own forms. This is known as symmetry breaking. In the very early universe, the rules might have been more simple, with no difference between the forces. As the universe cooled and changed, the forces split up and started acting in different ways. This splitting let the universe become more complex and allowed atoms, energy, and matter to start forming all the structures we see. As the universe continued to grow and cool, galaxies began to form from clouds of gas and dust. Gravity pulled these clouds into spiral and elliptical shapes. Inside them, new stars were born, planets circled around them, and over billions of years, galaxies grew bigger and joined together. Life was able to form on at least one planet because the laws of physics had just the right balance. Enough force to hold matter together, enough energy for atoms to move and join, and enough stability for long-lasting objects to exist. Every stage in this story, from the first moment to today, was possible because of the laws that turned on with the universe. If the forces had not separated, or if they had different strengths, the universe would look very different. There might be no galaxies, no stars, and no chance for life to exist. The first moments also left small marks or patterns that scientists look for today. For example, the small differences in the amount of matter from place to place in the early universe became the seeds for galaxies and clusters of stars. The light from the cosmic microwave background still shows some of these patterns. By measuring this light very carefully, scientists learn more about the first few 100,000 years after the beginning and how the laws of physics worked even then. The temperature and density at the very first moment were much higher than anything we can create today, even in the best laboratories. The laws of physics under these extreme conditions might reveal new details if we could test them. Some scientists build big machines called particle accelerators, which smash tiny particles together at very high energies to study what happens. These experiments give hints about how things worked in the early universe, but there are limits. No machine can reach the energies that existed in the very first instant. Because of this, there are still mysteries about the beginning. Scientists ask whether space and time really had a first instant or if something stranger happened. Some think there could have been a time before the universe, different from anything we now understand. Others say that there was simply nothing, and then everything appeared at once. No matter the details, the main idea remains. The universe began at a moment when there was nothing, and then, suddenly, there was space, time, energy, and all the laws needed for everything that followed. The first instant led to everything else. The spread of galaxies, the birth of stars, the growth of planets, and the chance for life. This is why the question of the universe's first moment is so important. It is the starting point of every story, every fact, and every law. It is the point when the stage was built, the actors arrived, and the lines of the story were written, not in words, but in the silent language of physics, with numbers and forces, possibilities and limits. Today, when scientists look deeper into the universe, they always trace what they see back to this moment. They use telescopes to see light that started moving billions of years ago. They watch the patterns in the oldest light, study every detail, try new math, and search for clues about what really happened during the first instant. In all the data, the same truth remains. The universe and its laws began together, giving order and shape to everything that ever was and ever will be. Even though scientists know that the universe began a long time ago and that the laws of physics started working at that first moment, there is still much to learn about how it all happened. Scientists want to discover exactly how the laws appeared and in what order the changes took place. They want to know which rules were present at the beginning and whether any new laws appeared later. But because it is not possible to travel back in time or to see the universe's first instant directly, scientists must find other ways to investigate these deep questions. Since there are no direct pictures, sounds, or messages from the very beginning, scientists use the clues that remain in the universe today. They look for traces written into the oldest light, into the patterns of galaxies, and into the way atoms and particles behave. Every detail they observe is like a small note left over from the history of the universe. Each bit of information helps scientists test ideas about how everything started. One important clue is the cosmic microwave background. This is faint light that fills all space and comes from a time about 380,000 years after the universe began. Before this time, the universe was so hot and dense that light could not travel freely. Particles of matter and light collided again and again. When the universe became cool enough, atoms could finally form and light was able to move in straight paths. This old light is still traveling through space and can be seen with special telescopes. By studying the cosmic microwave background, scientists learn important facts about what the early universe was like and how the laws of physics shaped everything in those first years. Another way scientists explore the beginning is by watching how galaxies are spread out across space. Galaxies do not stand alone. They form clusters and patterns that are connected. These shapes did not appear by accident. Gravity, energy, and the laws of physics guided where matter gathered more thickly and where it spread out more thinly. By measuring these galaxy patterns, scientists learn about the strength of gravity and about other rules that controlled the earliest times. Atoms themselves are also full of ancient clues. Each atom is mostly empty space, with a small nucleus in the center and electrons holding to it at precise levels of energy. Scientists have found that these rules have stayed exactly the same since atoms first formed. Light from distant stars and galaxies shows the same patterns as atoms here on Earth. This means the basic laws of nature have not changed, even after billions of years. But how do scientists actually study things they cannot see or touch? One important tool is mathematics. Scientists use math to build models of what the universe was like in the past. These models are like detailed descriptions that can be used to predict what should be seen if the models are correct. For instance, by writing down equations for how space expands and how matter moves, scientists can estimate what temperature the universe should be at any given time and how big it should appear today. When the results of these calculations match what is measured in the sky or in laboratories, it gives confidence that the models are correct. For example, the temperature of the cosmic microwave background was predicted using the laws of physics. Then, when special satellites measured this background, they found its temperature matched what scientists had guessed based on their math. This agreement supports the idea that the laws of physics have stayed the same from the beginning of the universe up to now. Another tool is laboratory experiment. Scientists build powerful machines that crash tiny particles together at high energy. When two particles smash into each other, they break apart into smaller pieces or turn into pure energy, copying some conditions from the very early universe. Studying these collisions helps scientists figure out what might have happened in the first seconds after the universe began. Even though no machine can create the exact conditions of the very beginning, each experiment gives useful clues. Computer simulations are also important. Scientists create virtual universes inside computers using the laws of physics and starting with the early conditions. The simulation shows how matter should move, how galaxies should grow, and how light should travel. If the simulated universe ends up looking like the real universe, with similar galaxies and similar patterns in space, then it means the starting ideas were probably close to being right. Observing supernovas, or exploding stars, gives clues about how fast the universe is growing. By measuring how bright and far away these events are, scientists can figure out the rate of expansion. This helps them connect today's universe to the one that existed long, long ago. These measurements, combined with the study of other old light and distant galaxies, make it possible to test ideas about how the universe has been changing since the first moment. Sometimes scientists find unexpected results in their measurements. If numbers from the sky or from experiments do not match the models, it may mean that something needs to be changed or added to the understanding of the laws of physics. For example, scientists discovered that the universe is expanding faster than they once thought. To explain this, they added the idea of dark energy, a kind of strange energy that pushes the universe to grow faster and faster. They also know that most matter in the universe is invisible. It does not give off light and is called dark matter. These discoveries come from careful observations and would not have been noticed without testing the smallest differences in the night sky. Another piece of the puzzle is looking for very rare or special kinds of particles. Scientists have made detectors that are buried deep underground or float in space, ready to catch particles that pass through everything, such as neutrinos. These ghost-like particles were formed soon after the beginning of the universe and carry stories about the first moments. Even though it is very hard to measure them, each one gives more information about how matter and energy acted when the universe was young. Some experiments study atoms very carefully to see if there are any hidden changes over time. For example, scientists compare very stable clocks, called atomic clocks, that use the vibrations of atoms to tell time. By checking if these clocks stay perfectly matched as years go by, scientists can tell if the laws of physics are truly unchanging or if they might shift little by little. Astronomers also look at light from objects far away and from long ago. Since light moves at a fixed speed, when we see light from a very distant galaxy, we are seeing how that galaxy looked billions of years before. The color and brightness of this light reveal the kinds of atoms in those galaxies and what the laws of physics were like back then. Again and again, the results show that the rules have not changed, no matter how far or how long ago the light began its journey. All these different tools, mathematics, experiments, telescopes, and computers, work together. By combining the information from each, scientists make their best guesses about the earliest times, including what the laws were, how matter changed, and how energy behaved. Each new discovery helps to fill in another piece of the puzzle. One reason this work is so slow and difficult is that the first moments of the universe are hidden behind a wall of heat and energy. Before a time about 380,000 years after the beginning, the universe was so hot and thick with particles that light could not move freely. Because light was trapped, there are no direct images from this earlier time. The cosmic microwave background is the oldest direct history we can see. All events that happened before this left only indirect traces, stored in how matter is arranged, or in tiny details in the background light. To learn about even earlier moments, scientists must use very clever ideas. They study how the laws of physics work when matter and energy are very, very hot and dense. They use powerful math to guess what could happen if the universe was smaller than a grain of sand, but had all the energy of everything there is. Some of their ideas cannot be tested directly, but their predictions can sometimes be checked through careful measurements and by looking for small effects in the universe around us. As scientists dig deeper, they sometimes find questions that are still too difficult to answer. For example, was there something before the universe began? If so, what was it like? Are there signs of hidden rules or pieces that appeared and then vanished before the universe became cool and calm? Are the patterns we see today, like the shapes of galaxies, the forms of atoms, and the spread of light, leftover marks from that earlier, unknown time? One area that gives hope for new answers is called quantum physics. This kind of science studies the tiniest parts of matter, smaller than atoms. At this size, the normal ideas about space and time stop working in the way we expect. Particles can act in surprising ways, sometimes popping in and out of existence. By learning how quantum rules might have helped the universe begin, scientists hope to discover how space and time themselves started, and whether the laws of physics can pop into being from nothing. But every idea and model is checked by real observations. Even the most exciting new theory must agree with what is actually measured in the sky, in atoms, and in the patterns of light. This is what makes science different from guessing. Every answer must match what is real. If the numbers do not fit, the idea has to be changed or a new explanation has to be found. All of this searching takes patience and many years. Scientists repeat their measurements, check their math, build better tools, and look at new parts of the sky. They share their results with others, so anyone with the skill and tools can repeat the tests. Science is built on evidence that others can see, not just on ideas or beliefs. Sometimes new tools bring big surprises. When powerful new telescopes are built, or when a new type of detector is created, things that nobody expected can be found. For example, in the last few decades, space telescopes have spotted strange changes in the light from faraway stars and galaxies, showing that the universe is not just expanding, but is speeding up as it grows. These discoveries force scientists to think again about what the universe is made of and how the laws that guide it might be more subtle than first thought. Computer power also grows every year, letting scientists do bigger simulations and test more ideas. These virtual experiments show what galaxies should look like, how matter should move, and how the universe should grow if certain laws apply. By comparing these simulated universes to the one we see with telescopes, it becomes easier to know which rules fit best. Another path scientists take is studying the motion of the smallest and largest things together. When tiny particles like protons and electrons are studied closely in laboratories, And when giant black holes and galaxies are observed in space, scientists want to find rules that explain both. Sometimes the laws that work very well for big things do not match perfectly with the laws for small things. This shows there is still more to learn about how all the forces and rules join together. There is also careful work done with time. Since the universe has been changing for almost 14 billion years, every clue collected comes from a different time in history. Putting all these clues together is like building a very large, very old puzzle. Some pieces are lost, some are hard to see, and some may be missing, but every new detail can make the picture more clear. Even with all these careful steps, scientists know there are limits to what we can find out. Some moments, like the very first split second after the universe began, might always be hidden. There may be parts of the universe that light and signals cannot ever reach us from. The laws of physics may have special rules that keep certain events forever out of our reach. But even when the past is hard to see, people do not stop looking. With each discovery, scientists learn not only about what happened, but about how to ask better questions. They improve their instruments, their experiments, and their ideas. The search for the universe's beginning is a journey with no final stop because every answer opens a new question. Every person who looks up at the stars, who reads about atoms or galaxies, or who wonders what happened before anything existed, is part of this search. The traces of the beginning of the universe are all around us, in every bit of matter, in every flash of light, and in the laws that quietly control everything we see and do. Even though nobody has yet found every piece of the puzzle, every small detail discovered, every tiny new clue found in the sky or in tiny particles, helps us take another step in understanding how the universe and its laws began. The constant work to uncover these answers leads to new thoughts, like whether the laws of physics might be tied to the universe itself, or if the rules are something deeper that give rise to the very world we live in. When scientists search for clues about the beginning of the universe, they find that every new discovery leads to deeper questions. One of the most puzzling questions is about why the laws of physics exist at all. People want to understand if the rules of the universe are separate from the universe itself, or if the laws and the universe appeared together at the same time. This question is important because it helps explain what might be possible, what things can exist, and why the world is the way it is. Much of what scientists observe makes them think that the laws of physics might not exist alone, before or outside the universe. The idea is simple. Without space, time, or anything else, rules cannot work. There would be no things for the rules to control. If nothing exists, there is nothing to follow rules, nothing to move, and nothing to change. The rules themselves have no meaning if there is not a universe where they can act. When the universe started, it was not just energy and matter that came into being. The shape and order of the universe were also set. This includes the way space stretches, the way time flows, and the way matter and energy act. All these things are fixed by the laws of physics, but those laws could only start to work once the universe started to exist. In this way of thinking, the universe and its rules are like two parts of one single beginning. The rules that guide gravity, light, electrons, atoms, motion, and energy did not appear before the universe. Instead, they came into being at the first instant, when all things began. The roles of these laws are not written down somewhere outside or above nature. They are part of the universe itself, woven into every atom and every star, present from the very first moment. Some scientists think of the laws of physics as properties of the universe, similar to how wetness is part of water or how color is part of light. If there is no water, then there is no wetness. If there is no light, there is no color. In this view, without the universe, there are no laws. As soon as the universe is born, the laws come to life as well. This idea changes how people think about what came before the universe. It suggests that before is not a meaningful idea in this context because time only began when the universe began. There is no before for any event, any object, or any rule. The first instant of time is the first instant of every possibility, every location, and every law. The universe comes with its rules, all tightly linked, because the laws of physics are bound to the universe. They only make sense within the universe. There are no signs, no information, and no patterns pointing to a time or place when the laws could have existed on their own. This is very different from the way human laws work, where rules are written by people and apply wherever people agree to follow them. In the universe, the laws exist because the universe exists. The two cannot be separated. From the very first moment after the universe began, everything that happened was shaped by these laws. The way matter gathered, the way atoms joined, the way stars started to shine, all followed the rules that became real at that very first instant. There was not a period when matter waited for the rules to arrive. The laws and the universe were born together as two sides of the same event. This way of thinking helps people understand why the universe looks so organized. As soon as space and time began, the possibilities for what could happen were set. The laws told matter how to act, told energy how to move, and told everything how to change from one instant to the next. There are no places where matter or light can break free from these rules. All things, everywhere and always, must obey. Another important result is that, in this picture, there is no outside of the universe. If someone asks where the universe is, the answer is, the universe is all there is. The laws of physics are not waiting outside for the universe to begin, and there is no bigger space where rules float around. All space, all time, and all rules come together as the universe appears. This also helps explain why searching for the origin of the laws of physics is so hard. If the rules only exist together with the universe, there are not and never were any meta-laws or deeper rules that set them before space and time began. Instead, the beginning is the moment when all things start at once, including the possibility for rules and for change. Some scientists like to use the word emergence. This word means that something appears as a result of other events or conditions. In this case, the laws of physics emerge with the universe. They do not exist as blueprints waiting to be used. As soon as there is space, there are distances for laws to control. As soon as there is time, there are changes for the laws to guide. As soon as there is energy and matter, there are things and forces to shape. Nothing is there first. It all comes to life together. This idea also avoids the problem of asking what was before the universe or what caused the universe. If there is no time, there is no way to say before. If all the rules and space and time come into being at once, there is no separate moment or cause. This is very difficult for people to think about because in daily life, everything seems to follow a cause and effect, with one thing leading to another in time. But the beginning of the universe is special. It is the moment when the flow of time itself becomes possible, and along with it, all the ways for things to happen. Thinking about the laws and the universe as joined can bring other questions. For example, could there be other universes, each with their own rules? If that is possible, what decides which laws belong to each universe? Or is our set of rules the only possible way for things to exist? Scientists do not have full answers to these questions, but the idea that laws and the universe are born together is a strong starting point. This way of seeing things matches what scientists find in practice. Whenever they look at nature, they see the same rules everywhere. They do not find anything that works differently somewhere else, or any place where the rules disappear. This tells us that the laws of physics are universal and probably have been the same since the moment time began. As scientists continue to test the universe, they always look for signs that rules could change or that something acts outside the laws. Every new measurement, every new experiment, every new telescope image is an opportunity to search for exceptions. So far, no exception has ever been found. No evidence shows that the laws existed before the universe. No machine, no clock, and no light from the farthest stars has given a hint that the rules could be separated from the world they control. Some scientists study the strange patterns found in quantum physics, the area of science that explains the smallest parts of nature. At this tiny scale, the rules are different from normal life, but they are still rules. Even though things can be unpredictable or seem random, these effects follow specific patterns, decided by the same laws that shape atoms and light. The quantum laws are woven into the universe in the same way gravity and motion and energy are. Since every way we have found to study the universe depends on the rules being always the same, scientists have to use very clever tricks to ask about the very start. They look at what is possible, what is necessary, and what the rules let happen. They think about which rules must appear together, and whether it would ever make sense for a universe to exist without rules at all. Some scientists and philosophers play with the idea that there could be places outside our universe where different laws are possible, but this is a very hard idea to test. There are no telescopes that can see outside the universe because space and time are part of the universe itself. There are no ways for signals, light, or matter to travel to or from anywhere else. For now, all science can do is look at this universe where every part obeys the same laws that began at the first instant. When people ask why the rules are the way they are, it often comes back to the fact that the universe and the laws are not separated. There is no answer for why in the way people are used to. The rules are because the universe is. If there was no universe, there would be no rules. And if there were no rules, nothing could happen. Only together do they both make sense. As the world became more ordered, as atoms joined into stars and stars made new elements, the laws kept shaping everything. Planets formed from dust, orbiting around stars because gravity told them how to move. Air and water, heat and cold, pressure and light all acted according to the rules. Every tree that grows, every animal that moves, every child that laughs is following the same set of laws that came into being at the beginning. This idea changes the way people think about the meaning and place of the universe. Instead of imagining rules that exist in another world, people understand that the rules are found in everything around them. Rocks, oceans, sky, light, and even the spaces between stars. Everything is connected. Everything is shaped by the same underlying patterns, and nothing can exist apart from these rules. If the laws and the universe are forever joined, then the only way to learn about the origin of the rules is to study the world itself. Looking at how galaxies are arranged, how light moves, how atoms behave, all gives hints about the first moment and about what is possible and impossible. Each measurement is a window into both the story of matter and the story of the rules that shape it. Some theories suggest that maybe the rules could be slightly different in other worlds or under other conditions. But until scientists find evidence for this, the best answer is that the universe and its laws are two parts of one soul, making everything possible and setting every boundary. Over the years, as science has uncovered more details, the sense grows that the universe is not just a collection of objects, but a single grand story written by its laws. The laws began at the first instant and have written every moment since, deciding the path of every star, the dance of every particle, and the shape of every galaxy. There are mysteries left and questions still open, but at the core is a simple truth. The laws of physics and the universe are joined. They both started at the same time. They both shape everything we see, touch, know, and imagine. Without one, the other cannot be. This idea stands at the heart of what it means for anything at all to exist. When people ask if the universe and its laws are tightly connected, new questions appear. Some scientists wonder if there could be other kinds of universes, not just this one. They suggest that there might be many universes, each with a different set of laws, a different way space and time behave, and even different possibilities for matter and light. This idea is called the multiverse. The thought of a multiverse comes from trying to understand why the laws of physics in our own universe seem very special. If gravity were a bit stronger or weaker, stars might never form, or all matter could collapse very quickly. If the numbers that describe how electricity and light work were slightly different, no atoms could ever join together to make the things we see. There are many details in the laws of physics that seem just right for galaxies, stars, planets, and living things to exist. This makes some people ask, are these rules the only way things can be, or are there other laws somewhere else? Could there be universes where gravity does not pull things together, or time moves in another way, or even where matter and energy do not exist at all? The multiverse is the idea that there may be a huge number of universes, all very different from each other. In the multiverse picture, some universes may have rules that are similar to ours, while others are extremely different. Some universes might be completely empty, with no matter, no light, and nothing ever happening. Others could be filled with lots of matter, but no stars, because the laws do not let matter come together in ways that make stars possible. Some universes could last only a tiny instant before vanishing, while others might keep expanding forever. If there are many universes, the one we live in may not be special in any deep way. Instead, we live here just because the laws and numbers in this universe allow things like stars and people to exist. In universes where the laws are very different, nothing like us could ask questions, because nothing could ever be built up from atoms, and there would be no life or order at all. This picture moves the big question to another place. Not why do these laws exist, but why do we see these laws and not others? Some scientists say that the only reason we notice the universe is because the rules in this place allow for observation, thought, and life. If the rules were different, there would be nobody to see anything or to wonder about the universe. The multiverse idea first became popular when scientists saw that the laws of physics could have many possible values. In some versions of physics theories, such as those that try to join together gravity and quantum mechanics, there are ways for many different sets of rules to appear. In these theories, each universe chooses its own set of laws when it begins, depending on conditions that are not fixed by any reason. One place scientists explore the idea of the multiverse is in a theory called cosmic inflation. Inflation is a very fast expansion that happened in the first instant of the universe. In some versions of this theory, inflation does not just start one universe, but creates endless bubbles, each one growing and becoming its own universe. Each universe bubble could have its own laws, its own particles, and its own forms of energy. In this view, our entire universe is just one bubble surrounded by countless others we cannot see or feel. Each bubble is its own space with its own past, present, and future. The laws inside one universe need not be the same as the laws in any other. They could be similar or completely different, set by what happened when each universe began. Another idea comes from string theory, a scientific approach that tries to explain all forces, particles, and rules with tiny vibrating strings. In string theory, there are many ways these strings can vibrate, and each way leads to a different kind of universe with its own laws. There could be an enormous number of possible combinations, making a landscape of universes with all types of logic, numbers, and properties. So, if so many universes are possible, why do we only observe this one? Scientists answer that we can only see the universe where life is possible. All other universes with laws that would never let atoms join or stars shine would be empty and silent forever. The laws in our universe are not special, except that they allow beings like us to appear, to notice, and to ask questions. Even though the idea of a multiverse is interesting, there are problems with testing it. Since each universe is separate, nothing can move from one to another. No message, no signal, not even light can cross from one universe to another. Because of this, the idea of the multiverse is difficult, maybe impossible to confirm with experiments or observations. It is very different from most science, which depends on making tests and seeing results. Still, some scientists look for signs that might show our universe touched another one at some time in the very early past. They search the cosmic microwave background for strange patterns or marks that do not fit usual models, hoping to find a hint that another universe left a trace on ours. So far, none of these possible signals have been found. Even without direct evidence, the multiverse helps scientists think about why our universe is the way it is. It gives a possible reason for why the laws of physics here seem so well set for life and order. In the multiverse picture, it is not a surprise to find ourselves in a universe with friendly laws. It could be that, among countless universes with all kinds of rules, we are in one of the few where stars, atoms, and living things are possible at all. This idea is also called the anthropic principle. The word anthropic comes from a Greek word that means human or person. The anthropic principle says that the universe must have laws that allow living beings to exist and observe it, or else there would be no one to notice that universe in the first place. In universes with the wrong rules, no life ever starts, and there is nobody to ask questions. Some people do not agree with the idea of a multiverse because it is hard to prove. If something can never be observed or tested, it does not fit the usual work of science. Science is built on things people can see, measure, or check. But for now, other universes are invisible, out of reach of our instruments and tools. Others think the multiverse idea helps solve puzzles about our own universe because it explains why so many things are exactly right for life. Instead of being surprised, they say, it just means that in the countless universes, life will only ever happen in the ones with friendly rules, and that is where someone would ever ask a question. Even so, the multiverse is only one idea. Scientists also search for other explanations for why the laws are this way. They look for deeper patterns or reasons that might make these numbers and rules necessary, not accidental. Every idea is checked with the universe we can observe, and every theory must agree with everything we can measure. If the multiverse is real, it makes the story of the laws of physics even bigger. Instead of one answer, there may be endless answers, one for each universe. In that case, the question science can solve is why the laws here allow for life and order, not why these are the only rules possible everywhere forever. The thought of many universes also leads to new questions. Is there any way for these universes to affect each other? Can laws ever change from one universe to another? Is there a deeper meta-rule that explains why so many different universes can appear at all, or why the landscape of possible rules takes the shape it does? Right now, There are no clear answers. If there is a deeper set of rules or meta-laws, nobody knows what they are or how they might work. Some scientists think there must be some reason for the choices of laws. Others think it may be just chance. Either way, the idea of many universes makes people think more deeply about what is possible, what is accidental, and what is necessary in the laws of nature. The study of the multiverse has affected other parts of science too. For example, it raises questions in philosophy about what is real, what counts as evidence, and how people can know what is true in a universe that they cannot see or touch. It changes how science and human thought are connected and how small and large the universe can feel at once. If there are countless universes with different laws, that would mean there are countless ways for space, time, matter, and even life to appear. Some rules would be better for making stars and planets, while others would not allow anything interesting to form. Some universes would be silent and dark forever, while others could make life that is very different from anything here. Some versions of the multiverse even say every possible history exists somewhere, that every possible outcome of every event is played out in a different universe. These are big ideas and can be very hard to think about, but they show how strange and wide reality might be outside the small world we know. Even if no evidence for the multiverse is ever found, the idea has already made people think more about the laws of physics. It has encouraged scientists to look for new patterns, to test why rules are the way they are, to ask whether more fundamental laws could exist, and to be open to answers that are different from what has been imagined in the past. Every step in this search depends on something simple that people do every day: asking questions, checking facts, looking for explanations, and listening to what the evidence says. As long as science is guided by this method, even the deepest mysteries can be explored. Whether the universe is one of many or the only one, all of the evidence comes from the world we can see and measure. The search for deeper understanding continues, whether the answers are about what our universe is like, or about why some rules seem unbreakable, or about how one set of laws can control so much from the smallest thing to the largest. This search also raises another set of questions. If there are many possible universes, are the laws in our universe special in any way? Could deeper reasons explain why gravity, light, and other forces work as they do, making life possible? Or are all rules just possible choices, and we happen to live where the pieces fit together for stars, planets, and living beings to exist? Scientists keep looking for clues by checking how atoms work, how galaxies gather, and how the oldest light is spread in the sky. Every clue is measured against different ideas, including the thought of many universes. With every test, scientists come closer to understanding if the laws in our universe are unique, accidental, or part of a much larger and stranger story. People may never know for sure if the multiverse is real, but the question itself helps guide science. It reminds everyone how much there is to learn and how many secrets the universe still holds about its origin, its rules, and the meaning of everything that exists. The journey to find why the laws are so special continues, searching for a reason, a pattern, or a hidden explanation that goes beyond what is known today. As people continue to look for answers about why the rules of the universe are the way they are, more questions appear. Scientists are not only interested in what the laws of physics are, they also want to know if there are reasons why the laws have these exact forms and numbers. They investigate if something deeper controls which rules can appear and why the universe has the special details it does. Small differences in the details of the laws of physics could make the universe very different. Scientists notice that the strength of gravity, the way atoms join, and even the amount of energy in empty space all need to be just right for stars, planets, and life to exist. If these details were even a little different, the universe might not have any places where living things can grow or survive. For example, gravity must be weak enough for stars to shine for a long time, but not so weak that galaxies never form. The strengths of the forces inside every atom must allow nuclei to hold together, but not be so strong that all matter is crushed. Light must move through space with a speed and energy that allows heat and other types of energy to spread in ways that support life. The more scientists study these numbers, the more they see how balanced they are. This situation is sometimes called fine-tuning. It means many details in the universe's rules seem adjusted with care, as if they had to be this way for things to work. Scientists do not know if this is just a coincidence or if there is a deeper explanation waiting to be found. One possible reason is that these rules and numbers are just an accident. In this view, the universe began, and the laws came with it, without any special reason. If the laws had been different, a different universe would have formed, or maybe nothing interesting would have happened at all. This is one possible answer, but many scientists look for more than just chance. Another reason could be that there is a pattern or a deeper set of rules, sometimes called meta-laws, which control what laws and numbers can be allowed in any universe. These would not be rules about stars or atoms, but rules about what kinds of rules can exist. If such meta-laws exist, they would decide whether some laws are possible or set limits on the details of gravity, light, and matter. Scientists search for clues about these deeper reasons in many ways. One way is by looking for patterns in math. Physics uses many different types of mathematics to describe the world. Often, the simplest and most elegant math leads to the laws that are found in nature. Some scientists believe that the universe chooses the most simple or beautiful math possible, and that this is why the laws look the way they do. Other scientists study the connections between the different forces. At first, people thought gravity was unrelated to electricity or the strong and weak nuclear forces inside atoms. Over time, they discovered that, at extremely high energy, these forces may be parts of a bigger whole. If all forces come from one simple idea, it would explain why the rules must look this way. This is called unification. Unification tries to show how all the rules come from one deeper source. For example, some theories join electricity and magnetism as parts of the same force. The next step is to join all the forces, including gravity, but this is still an unsolved problem. If scientists ever find one idea that explains everything, that would be an answer to why the rules and numbers have the values they do. Some scientists believe symmetry is important. Symmetry means that when you change some part of a system, the system still looks the same or works the same way. Symmetry helps decide what is possible and what is forbidden in physics. In many cases, the laws that have more symmetry are more likely to work for the whole universe. This could mean that deeper symmetries shape the laws of nature. Other clues come from the way the universe has evolved since the beginning. For example, the oldest light in the sky, the cosmic microwave background, still shows faint marks from the first moments. Patterns in this light suggest that some features of the laws were set at the very start. Scientists use data from telescopes and satellites to measure these patterns, looking for hints about hidden reasons behind the laws. Sometimes the search for deeper reasons means breaking the old rules and trying new ideas. For instance, some researchers have proposed that gravity could change in different places or times, or that the speed of light might have changed in the past. If such changes were found, it could mean that what we call constants of nature are not always fixed. So far, every measurement shows that the laws and their details have not changed, but the search continues. Physicists also ask if certain details are needed so the universe can make complex things. This is called the principle of selection. Only universes where the conditions allow atoms, stars, and life can be observed by anyone at all. In universes with the wrong rules, nothing interesting happens, and there are no observers. In this view, the observed laws are special only because we can notice them. This principle of selection is related to the idea of the multiverse. If there are many possible universes and each tries different laws, then only in the universes with the right balance will life appear. This does not give a reason for the laws, but it gives a reason why someone finds themselves in a universe with such special numbers. Even so, many thinkers hope there is a more satisfying answer. They keep looking for patterns, hidden rules, or deep mathematics that will show why things must be this way. Discovering a deeper reason would answer one of the oldest questions, showing not just what the world is, but why it is the way it is. Sometimes scientists study very tiny numbers like the ratio between the mass of the proton and the electron, or the force of gravity compared to electricity. These numbers do not seem related to each other. Why should they have just these values? If even one of them was changed a little, the world would be unrecognizable. Planets would never form, stars could not shine, or atoms might not exist. Many laws in physics are written as equations, and inside these equations are special numbers called constants. Some constants have no units, meaning they just compare two things. For example, the fine structure constant controls how strong electricity and magnetism are compared to other forces. These constants control everything, but no one knows why these numbers were chosen. Each new experiment checks if the constants are always the same or if they might change over time or in different places. There are also puzzles about the amount of energy in empty space, called the cosmological constant. This number is very small but not zero. It controls how fast the universe grows over time. If it were much bigger, the universe would have stretched apart too quickly for stars and galaxies to form. If it were smaller or negative, the universe might have already collapsed. No one knows where this number comes from, but it is key to how the universe has changed. Some researchers look for deep connections between these numbers. They see if the constants in different laws fit together or come from one cause. A few ideas in mathematics show that the constants we see may be the only values that avoid problems, like infinite energies or impossible situations. This search is not finished, and nobody has a final answer yet. To collect better data, scientists use more and more advanced experiments. They build huge telescopes that see farther and with more detail, satellites that look for patterns in the oldest light, and particle colliders that smash atoms into smaller pieces, revealing details from the universe's first moments. Every experiment tries to check if the laws could be different or if any small change is possible. In recent years, computer simulations have become important in this search. Powerful computers are used to build models of the universe, starting from simple ideas. These models show how tiny changes in the rules or constants would make a universe that looks different. Many of these simulated universes lead only to empty space or chaos, but the real universe fits only a small region of all the possibilities. This shows how narrow the path is that allows for things like stars and life. Physicists also keep searching for new laws. Sometimes they find new forces or particles hiding in data that does not fit old ideas. When something very odd is found, like a new kind of particle or an unexplained motion, they test if it fits with the present laws or if it breaks the known patterns. If it does not fit, it may point to a deeper explanation for why the world follows its current rules. Another approach is to test nature where conditions are extreme, such as in black holes or at the moment the universe began. The mathematics of extremely high energies and densities might show why some choices are allowed for the universe and others are not. Some new theories try to explain how the features of the world freeze in during the first split second of existence, fixing the values of the constants forever after. In addition to science, the search for deeper reasons also leads to philosophical questions. People ask if the universe needs a reason at all. Maybe there is no answer except that is just how it is. Or maybe our ideas of reason and cause do not apply to the birth of the universe in the same way they do to other things. The discussion goes on, and each new discovery changes how people see the question. When children and adults ask why the world is this way and not different, they join a long history of curious minds. Every person who wonders about the stars, the earth, and life is part of the search for deeper reasons. Some may believe that science will one day answer every question with a clear rule or cause. Others think there will always be some mystery left. The search for patterns, causes, and explanations is what drives science. Every new law discovered is both an answer and a new question. Why is this the law and not some other? Every number measured, every constant found, every detail explained leads to more ideas about what could be. The universe, with its rules, forms a puzzle that is still not finished. With each generation of scientists, new tools and ideas are added to the search. New telescopes find distant light from the first stars. New computers show how small changes can make huge differences, and new theories hint at hidden connections or possible laws no one has dreamed of yet. The puzzle of why the laws and numbers of the universe are what they are keeps getting deeper. Even as the search goes on, one question remains open. Is there a final answer or deepest reason? Will people ever know exactly why these rules exist and not others? Or will the universe always keep some secrets with the details balanced in ways no one can ever fully explain? The work continues, with each piece of data taking scientists closer to understanding how the laws of nature were chosen, or had to be chosen, to make the world that everyone knows. Across all the questions about why the universe has its laws, there is a special area of physics that brings even more mystery. This is the science of the very small. It is called quantum mechanics. Quantum mechanics looks deeply at what happens when things are smaller than atoms. In this world, strange things happen that do not seem possible in ordinary life. In quantum mechanics, some things do not follow simple rules as clearly as larger things. Particles like electrons or photons do not always have one fixed position or speed. Instead, they can act in ways that cannot be fully predicted. Sometimes these particles behave as if they are in many different places at once. Other times they seem to make choices that happen by chance. This does not mean there are no rules. The rules are just different from what people see every day. They are written as probabilities and chances instead of in certain steps. The way quantum mechanics works has changed science in many ways. When people first studied quantum ideas in the early 20th century, they found that the very small parts of nature act in ways that are surprising and not like anything from the larger world. For example, light can act like a wave, or it can act like a particle. Electrons can pass through barriers that in normal life nothing could cross. Pairs of particles can act as if they are connected no matter how far apart they are. These strange effects are not just imagination. They have been seen and measured in laboratories. Quantum rules are very precise, even though they involve chance. Every experiment done with atoms and photons shows the same patterns over and over again. The math of quantum mechanics has allowed people to invent new technology like computers, lasers, and tiny electronics. Still, the deep meaning of what quantum rules really say about the world is still not fully understood. One of the biggest questions in quantum mechanics is about the start of everything. Scientists ask if the rules of quantum mechanics can explain how the universe itself began. In some ideas, space and time might not have needed a cause or reason. Instead, the universe could be the result of a quantum event that happened with no outside force. This is possible because, in quantum physics, small changes can happen with no clear cause at all. There are ideas in quantum mechanics that say particles can simply appear and disappear out of empty space. These changes are called quantum fluctuations. In normal life, nothing appears from nothing, but in quantum science, these tiny changes really do occur. In huge machines called particle accelerators, scientists see short-lived particles appear for a tiny instant and then vanish again. The energy that makes these particles is not borrowed from anywhere. It just comes and goes by the rules of quantum mechanics. This strange property has led some scientists to suggest that maybe the universe itself began with a kind of quantum event. In this idea, space, time, and energy all appeared in one moment as a result of quantum rules. There was no before, because time itself only started at that moment. The law that allows small things to change without causes might also allow the biggest thing of all, the universe, to appear without a cause. Some scientists have tried to use the math of quantum mechanics to describe what the start of the universe was like. One idea is that a quantum fluctuation in a state with no space or time could trigger the start of space and time. In this picture, the universe does not need an outside force to make it begin. The chance for the universe to pop into being is built into the rules themselves. Quantum ideas have other effects on the questions about the laws of physics. In the quantum world, there are many possible outcomes for every event, and which outcome happens cannot be known exactly before it happens. This is called uncertainty. It is not because our tools are not good enough. It is part of the basic laws. Even if you know everything that can be known about a particle, you still cannot predict everything about what it will do. This randomness is real. Scientists use these quantum rules to try to create models of the very first part of the universe. Some models say that the universe began very small, not with smooth space but with foamy quantum changes. As the universe grew, these quantum patterns became the seeds for the galaxies and stars we see now. Even some of the details in the cosmic microwave background, those tiny differences in temperature across the sky, may come from quantum fluctuations stretched out when space grew quickly in the first instant. Another important part of quantum mechanics is called entanglement. This kind of connection happens when two particles are linked in such a way that a change in one instantly affects the other, even at long distances. Some scientists wonder if the first state of the universe was a single entangled whole, connected in a way that is lost as the universe grows larger. They ask if quantum entanglement could help explain how the laws of physics are the same everywhere, even in places too far apart to have ever touched. Quantum mechanics also lets scientists imagine universes that are very different from ours. Some ideas suggest that with every quantum event, new possibilities split off, making other places where different things happen. These are not universes we can visit or see, but they show how many possible histories can exist inside the quantum rules. The role of quantum mechanics in the start of the universe is still not fully known. No one has proof, but many scientists say these ideas give a way for something to appear from nothing if nothing is a state with no space and no time. Quantum rules allow the idea that even the biggest change, the beginning of space, time, and the laws, could happen with no outside cause just by the rules of chance. Understanding this is hard for people, because in daily life, everything seems to need a reason or a cause. Things do not just start without something making them start. But the quantum rules are different. Nothing is required to set things in motion at the very smallest scale. Whether this also works for the entire universe is an open question. Scientists keep working to make quantum ideas clearer and to see if they match what is measured in the world. In huge machines, tiny quantum changes have been seen that would never happen in the classical world. These patterns fit perfectly with the equations written by early scientists like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger. The predictions made by quantum math often match what is found in experiments to many decimal places. Some people worry that quantum ideas are too strange to be real, since quantum rules can allow something as simple as a particle to be in two places at once. But experiments show these are not just tricks of mind. They are real, and they affect everything from the energy in the sun to the electronics in every phone and computer. Scientists are still trying to find out how quantum mechanics and gravity work together. Quantum mechanics works for small things, and gravity works for big things, but putting both into one model is very hard. At the first instant of the universe, both gravity and quantum rules must have been important. Some scientists try to make new theories where they work together, called quantum gravity theories. These are not complete yet, but the hope is that such ideas will explain why space and time appeared and why the universe has the laws it does. Quantum science also brings more questions about the multiverse. If quantum rules allow so many possible events, do they also allow many different universes with different laws to begin as quantum events? Some models suggest that this is possible, and the universe we live in is just one result among many possibilities. This helps connect quantum questions with the ideas of many universes and many sets of laws. In laboratories, scientists make tiny pieces of material so cold that quantum effects become easier to see. They watch how atoms act, how they move together in groups, how they flicker in and out of sight. Every pattern seen in these experiments gives more proof that the rules of quantum mechanics are part of the world at every level. Quantum ideas are even used in new computers called quantum computers. These machines use the special power of quantum rules to solve problems that normal computers cannot. By building small quantum systems and measuring how they change, scientists learn more about how nature uses quantum laws. At the same time, quantum mechanics is used to look at very old things in space. The details of how light travels from the most distant galaxies, the ways black holes act, and the temperature of the youngest parts of the universe all seem to need quantum rules. Every result found so far agrees with the predictions of quantum mechanics. Even with all these successes, the question of how quantum ideas relate to the beginning of the universe is still open. The main challenge is that no one can see or test what happened at the very first instant. Models are checked in many ways, but the fact that quantum rules let things begin with no clear cause is still a puzzle. Another deep question is why quantum mechanics has the form it does. Why does nature choose probabilities and uncertainty as part of its deepest rules? Why do particles act as both waves and points? Is this the only possible way, or could there be other kinds of rules? For now, scientists do not know the answers. The search goes on. Scientists study mathematics, collect data, invent new experiments, and try to bring gravity and quantum mechanics together in one model. These efforts may someday show why the universe can begin, why laws can emerge, and why quantum rules are written into the heart of existence. The story of the universe's start is now a story about the smallest pieces and the biggest events coming together. Whether space and time come from a quantum event, and whether all the laws are the result of quantum rules, the mystery continues. At its heart, quantum mechanics lets scientists dream of how our universe and even other possible universes could pop into being with no need for anything before. Even though so much is uncertain, each new experiment and each new idea moves people forward. Every time an atom is measured, every time a particle flickers in or out of existence, every bit of energy that seems to appear from nowhere is a clue to the deepest questions. For now, quantum mechanics is the best answer to how things can happen with no cause, how the universe might begin from nothing, and how the strange, simple, and powerful rules of nature are written at every level. With every new question, the search for understanding grows, always seeking the reasons for the deepest patterns that made the world and continue to shape it at every instant, from the smallest particles to the entire universe itself. Even as scientists use quantum mechanics to think about the beginning of the universe and the rules that make everything possible, they are also looking for traces left over from the earliest times. Each piece of evidence in the present is a link to the very distant past. Scientists know they cannot reach back before space, time, and the laws of nature appeared, but they can look for signals that are still here today. These traces give valuable clues about what happened almost 14 billion years ago and how the rules appeared with the universe. One of the most important traces from the early universe is a kind of ancient light that fills all of space. This light is called the cosmic microwave background. It is not like the light people see with their eyes, but it can be detected by special instruments. This light has been traveling across space since a time about 380,000 years after the universe's beginning. Before that time, everything was too hot and dense, and light could not move freely. When the universe became cool enough, particles could stick together and make the first atoms. Then, light was finally able to travel in straight lines. The leftover glow is still present all around, filling every corner, but it is much colder and weaker than ordinary light. Scientists have built telescopes that can find and measure this ancient microwave glow. It comes from every direction and forms a kind of silent message from very long ago. By studying the small changes in the temperature and strength of the cosmic microwave background, scientists use math to work backward and understand what the early universe was like. For example, they look for tiny spots that are a bit warmer or cooler than the average. These small differences show where matter was a little more crowded or a little less crowded long ago. The details in these patterns help scientists test ideas about how the universe started and how the laws of nature worked at that time. The microwave background is not the only trace left from the beginning. There are other clues that come from the way galaxies are arranged in space. When scientists map the positions of millions of galaxies, they find that these galaxies make giant patterns. Some regions are more crowded, others are empty. These patterns also match what would be expected from small changes in the amount of matter in the early universe. The shape of these patterns depends on the way gravity works, on how matter and energy spread, and on what kinds of particles were present. By measuring all these patterns, scientists check if the laws of physics stay the same everywhere in the universe. Another kind of evidence comes from the elements themselves. The first few minutes after the universe began were very special. It was hot enough for simple nuclei of hydrogen and helium to form. Scientists call this period primordial nucleosynthesis. The number of hydrogen and helium atoms made then is fixed by the laws of physics. If the rules were different, the numbers would be different. By measuring how much helium, hydrogen, and other light elements exist today, scientists can check if their ideas about the early universe are correct. The match between predictions and actual measurements is strong, showing that the same rules work now as in the past. There are even more traces that scientists look for. One is the light from very far away galaxies, called red-shifted light. Because the universe is expanding, light that has traveled a long distance has been stretched and becomes redder. This change in color is used as a clock. The farther away the light comes from, the earlier it started its journey. By studying light from distant galaxies, scientists see them as they were billions of years ago. They can check if the patterns of galaxies and the types of stars match what is expected from the laws of physics. Another important tool is the detection of very rare particles, such as neutrinos. Neutrinos are almost invisible and pass through most matter without being stopped. Some kinds of neutrinos were made in the very first moments of the universe. Scientists build special detectors deep underground to try to find these particles. Each neutrino measured is a tiny piece of information about the universe very close to its beginning. Gravitational waves are also a new kind of clue. These are small waves in space and time themselves. When very heavy objects, such as two black holes or two neutron stars, crash into each other, they make ripples that travel across all space. By studying gravitational waves, scientists gain new information about the way gravity works and the details of the universe's history. Even small details in atoms carry messages from the early universe. Atoms are what make up everything: air, water, stars, planets, and living creatures. The way electrons move around the center of each atom is controlled by the laws of physics. Scientists can measure very small differences in the energy of atoms and compare those measurements to what they see in light from faraway stars. These checks can show if physical constants have changed over time. Sometimes scientists even look for traces in the structure of empty space. There are small differences in the way the universe expands in different directions. Careful measurements are needed, but each small effect helps test the ideas about the earliest times. If something strange is found, it could mean there is a new detail in the laws of physics that nobody has seen before. Scientists also look for clues in the ages and types of stars. The oldest stars contain mostly hydrogen and helium, just like the predictions about the early universe. Some very old stars have almost no heavier elements, meaning they must have formed early, before later stars created new types of atoms. By counting and studying these stars, scientists check the story of how the universe changed from simple beginnings to a place full of many kinds of matter. Another way to find traces of the early universe is to explore the speed of the universe's expansion. Scientists discovered that the universe is not just getting bigger, but is actually expanding faster over time. This was a surprise. To explain it, scientists included something called dark energy. No one knows exactly what dark energy is, but its effects can be measured through the way galaxies move apart. The amount and effects of dark energy are more traces about the way the universe works. Scientists also look for the effects of dark matter, which is a kind of matter that does not give off light or heat, but still has weight. It helps shape the way galaxies hold together, and its effects started very early in the universe. Even though nobody has ever held a piece of dark matter, the way it acts on visible things and on light is another clue about the rules that govern everything. Sometimes the traces are even more indirect. For example, the way light bends when it passes by a very massive object tells something about how gravity works. By measuring these tiny bends, scientists test whether gravity has always acted the same way or if it may have changed anywhere in the universe's history. To put all these pieces together, scientists use computers to run huge simulations. They start with the simple laws of physics and simple early conditions and let the universe grow step by step inside the computer. When the result matches what is measured with telescopes and detectors, it means the ideas work. If not, it shows that something is missing. These computer models now are more detailed than ever before, allowing scientists to test very small details across billions of years and great distances. Laboratory experiments play a part too. Scientists use large machines to copy some conditions of the early universe. By smashing particles together, they learn about forces, energies, and the way matter changed when the universe was very young. Every time a new detail is measured or a particle is found, it may be another piece of the puzzle. To find more clues, scientists build new and better tools. They put telescopes in space to avoid the blur of the Earth's air. Some instruments pick up microwaves, others see ultraviolet or X-ray light, and some detect particles instead of light at all. Every kind of instrument looks at a different piece of history. By comparing the traces gathered from all these tools, scientists can build a better picture of what happened. Sometimes traces are connected to chance. There are events called cosmic rays that come from space and hit the Earth. These are very energetic particles made in the explosions of stars or in black holes. Each event that is recorded helps complete the story of how the universe's laws made complex things possible. All of these traces tell a single story. The story of the universe growing from a very hot, small, and simple start into the place that now contains stars, galaxies, and life. Every piece of evidence, from ancient light to rare particles, shows that the same rules have guided things from the beginning up to today. By finding and testing more traces of the early universe, scientists answer more questions about the rules. Were they always the same? Did the laws change at any moment? Are there hidden details or unknown forces? Each measurement made adds a new point to the history of the universe and the tests of the laws. But sometimes the traces hold mysteries. Some things do not match what is expected. There are strange effects, odd patterns in the cosmic background, and missing pieces of matter or energy. Sometimes these odd facts show that something bigger is hiding in the way the universe works. Scientists look closely at these special details because one unusual result can lead to the discovery of a new part of nature. Patterns in the distribution of galaxies, the shapes of clusters, and the sizes of empty regions all carry messages about the laws that were present when everything first started. Each galaxy, each group of stars, moves and grows in ways decided by gravity, energy, and the shape of space. When scientists follow the path from now back to the earliest times, the details in these patterns suggest what happened in the first moments and if the laws can ever change. One other way to collect traces is by looking at the chemicals in interstellar gas and the movement of clouds. When light passes through clouds of gas far away, it picks up marks showing which atoms it met. These marks can be measured and compared with the way atoms should act if the laws are always the same. Over and over, the results show agreement, meaning the rules have not changed across time or space. Some scientists study the way gravity pulls on light from very early stars and galaxies. By measuring how strong the pull is in very old regions, it is possible to check if gravity has always had the same strength as it does now. Every time the numbers match, it supports the idea that the universe's laws are stable. Another deep search is for signs of cosmic inflation, the very fast growth that happened in the earliest split second of the universe. Some patterns in the cosmic microwave background might be traces left over from this event. To find these patterns, scientists measure the microwave glow with incredible accuracy, looking for tiny swirls and ripples. Finding these imprints would make the story of the universe's beginning more complete. New tools for finding traces are being developed all the time. Some scientists use radio waves, others measure changes in gravity's strength, and some try to find signs of new particles never seen before. Each new method is a way to reach deeper into the past, searching for messages about the oldest parts of the universe and how the laws came to be. Even though the universe's earliest times are hidden behind the wall where light could not travel, the footprints left in matter, energy, and space are still present. Each one is tested, retested, and added to the growing collection of facts used to build the full story. The search for traces is not finished. People everywhere keep making discoveries, finding new kinds of particles, and inventing more exact instruments. Each advance opens another path to understanding how the universe began, how the laws of nature appeared, and how all things grew from that first moment into the world known today. Behind every new observation is the desire to know if there is a deeper cause, a pattern, or a final rule behind all the facts. The more scientists look, the more they discover how much the universe's present is joined to its far past, and how the laws written in the earliest seconds are still guiding everything now. This search continues, driving questions about the meaning of the universe and the place of people inside it, always moving toward a fuller understanding of the laws that first appeared when space and time were born. Understanding the traces of the early universe leads to a much bigger question that touches everyone. People may look up at the sky or notice the world around them and wonder, why are the laws of physics so important? Why does learning about these rules truly matter in the lives of people? And what does it mean for how people see their own place in the universe? Asking where the laws of physics come from is not just a puzzle for scientists, but also a way for everyone to understand more about existence. The laws of physics set how everything works, from the smallest particle to the largest galaxy. These rules have decided the path of the universe since the very beginning. They control how stars shine, how planets form, how water flows, and how people can walk, breathe, and think. Without these rules, nothing would make sense or stay together. There would be no sun, no planets, no light, and no life. Learning about these laws is important because it connects people to the universe in a deep way. Every time someone moves, speaks, or thinks, their body and their thoughts are using the rules that started at the beginning of time. This connection means that the laws of nature are not just distant facts written in books or explained by scientists. They guide every part of daily life, from the cycles of day and night to the beating of every heart. Studying where the laws come from helps people understand the story of the universe. The universe is almost 14 billion years old. In all that time, it has changed and grown, but the laws of physics have stayed the same. This gives order to the world. Things that happen today can be explained because the same rules applied to things long ago. Understanding this story helps people feel part of something much larger and much older than any single person, country, or even all of human history. When people learn more about the origin of these laws, they see how special some parts of nature are. For example, the light from the sun is just the right kind for plants to use energy and for people to see. The force of gravity is strong enough to hold oceans to the earth, but weak enough for people to walk and jump. Atoms join together to make all kinds of materials, and these patterns are only possible because the rules are just the way they are. If any law were slightly different, the world could not be as it is. This special balance inspires people to keep searching for deeper answers. People want to know if there was a special reason for the universe to be built on these rules. Are the laws as they are because they must be, or is it possible that they could have been different? Is it chance, or is there a hidden pattern, a deeper explanation behind everything? These are questions that help people think about possibility, chance, and purpose. Asking about the laws of physics opens new doors of curiosity. Children and adults wonder how stars shine, how the seasons change, why things fall, and how anything can move at all. Every question about how the world works is really a question about the rules set by the universe. By searching for answers, people become explorers, looking for the deepest truths and learning more about what it means to be alive. Every discovery in science is built on understanding the laws of physics. Machines, medicines, bridges, and new technology become possible because people have learned to use these rules. The way a plane flies, how a computer works, or how doctors save lives all depend on the same patterns that were fixed at the birth of the universe. This shows that knowing the laws of nature leads not only to knowledge but also to the power to create, help, and improve life. The search for the origin of the laws is also a search for meaning. Some people wonder if the universe had to have these laws so that life could begin. Others wonder if it is just luck that everything fits together so well. By looking for patterns and deeper reasons, people try to find out if there is purpose and meaning in the order seen around them. Learning about how the universe started and why the laws exist as they do brings people together. Scientists from many countries, cultures, backgrounds, and ages work side by side to find answers. They share their results, test ideas, check and double-check every new piece of evidence. This teamwork is built on a common desire to know more, and it shows that the search for understanding is a worldwide effort. Every new experiment, every measurement is a small step forward. Even when answers are hard to find, each small detail that is learned makes the picture clearer. Sometimes discoveries lead to new questions. Sometimes a mystery grows deeper. But each result moves people closer to knowing the true shape of the universe and the rules that allowed the world to exist. This work is never finished, for there is always more to know. The universe is huge, and even today, most of it is beyond reach. New questions appear with every answer. For example, scientists now know about dark matter and dark energy, parts of the universe that people cannot see or touch, but which make up most of what exists. These discoveries remind everyone that not everything is known and that the hidden parts of nature are often key. By asking about the laws of physics, people also find limits to knowledge. Some questions may never be answered, such as what happened before the universe existed, or if there really are other universes with different rules. But even when a question leads to new mysteries, the search inspires new ideas, new technology, and new ways of seeing the world. The importance of this search is also found in how it changes people. Understanding the rules of nature can make people feel small, but it can also help people feel connected to everything around them. Every element in a person's body was made in a star. Every movement is shaped by forces set long ago, and every thought is made possible by the energy and structure given by the universe's laws. The rules that guide a falling apple are the same rules that shape distant galaxies. This unity helps people see life, Earth, and all experience as parts of a much larger whole. Sharing this knowledge is as important as discovering it. When people talk with children about the stars, the Earth, or the rules of motion and energy, they keep the search alive. Schools, books, documentaries, and museums all help more people join the search for understanding. Even simple questions like why the sky is blue or how birds fly open discussions about the laws of nature and encourage curiosity. In this way, the search never stops and new generations carry it forward. Searching for the origin of the laws of physics teaches people humility. It shows that no one knows everything and that wonder and discovery are always possible. Even with great tools, new machines, and powerful computers, mysteries remain. But this is not a reason to stop. It is a reason to keep asking, to enjoy the journey of learning, and to respect the beauty of the unknown. Many people feel awe when they look at the night sky, imagining the beginning of time and the vastness of space. This feeling is tied to the knowledge that people are part of the universe, not separate from it. Every law and every constant, every pattern in the stars is also present inside the atoms of every living thing. The study of the laws of physics also helps people think more about their responsibilities. When people understand how fragile life is and how rare the right conditions are, they may feel a new respect for Earth. Caring for the planet, using knowledge wisely, and protecting natural systems are all ways of respecting the rules that allowed life to begin in the first place. Sometimes, answers to big questions lead to new ideas in art, music, and stories. People find inspiration in the order and mystery of the universe. They write, draw, or compose using the feeling of being part of something much larger. The beauty of the universe's laws is not just in science, but in all parts of human experience. The journey to learn about the origin of the universe and its laws brings many gifts. It brings new technology, it helps cure illness, it allows travel into space, and it shows everyone the power of questions. But most of all, it gives a view of the world as a single, beautiful, connected whole, where every part follows the same deep and simple rules. Along this journey, people may find that answers are sometimes hard to accept. It is possible that there is no ultimate reason why these laws exist or why they are so finely tuned. The universe might be one of many, or it might be unique. Either way, the search itself is important because it shows the power of human curiosity, the wish to know, and the hope that learning can make the world better. Celebrating the search for the source of the laws of physics is, in the end, a celebration of being alive. It is a way of saying yes to curiosity and yes to the joy found in exploring and learning. It means seeing every day as a gift given by ancient rules, set long before people were here, yet still guiding every action and every breath taken. People everywhere, in every country and every culture, share in this journey. All people wonder about where they come from, why things are as they are, and what their place is in the universe. These questions unite people, showing that everyone is part of the same long story, a story written by the rules of nature from the beginning of time. As science continues, more mysteries will appear. Some questions may always stay open, and some answers may come in ways nobody expects. But as long as people keep looking for understanding, sharing what they learn, and respecting the mystery and beauty of the universe, the search for the laws of physics will continue. All people, through their questions, are part of this great effort, and together they help bring the secrets of the universe closer to the light.